Just wait a moment. Just wait a moment.
Okay.
You are live. Yes.
I am live. Okay. Welcome, everybody. I'm John May. I'm from FMC. I've been doing this type of technology work for about 20 years now for DuPont and now FMC. And what I want to show you is technology that we looked at in the last couple of years. So just as a little bit of an agenda, I want to talk about the history, what's gone on, and then what is FTIR. So I've kind of spoiled what the talk is about. Make sure we understand the rules because people seem to overuse or try to do more with this technology than is necessary. And then I'm going to give you a test by demonstrating the capabilities to you, and then a few extra points at the end, just so we're all on target and understand what's going on. So, and really, before I go too much further, I want to tell you, I don't sell FTIR spectrometers. I don't have anything to do with them. My desire is to promote the use of this technology. I don't have a team in this game. I just want to make sure that it gets used. So back in 2013, ECPA, the European Crop Protection Association, had an industry team put together that I led to look for an effective technology to rapidly or to detect fakes. And there were some criteria. It needed to be effective, and effectiveness was it can assess and detect all compounds, and it can identify in the pesticides that are being used. The second part was not quite so necessary, but being able to look at all compounds was needed to be low cost. So and even in the laboratory, if we had to have it done at a laboratory, it would be low cost for a lab. $200 for an analytical test is pretty cheap. It doesn't require a lot of maintenance. It needed to be common, so it needed to be something that you could find in a lot of laboratories throughout the world. Part of the reason for that is it's very difficult to ship crop protection products from one country to another unless you're doing it illegally, and that's not what we do. And also that there are multiple vendors, so you can negotiate prices with people to get a good price. And it needs to be rapid. So it's really simple to use, minimal sample prep, get results in 10 minutes, and it's semi-transportable or transportable. So the results of this work, I presented in the CPAC symposium in Liège in 2014. So let me just give you an idea about what technologies we did look at during that, for that team that CPAC put together. I just want to point out here, we didn't just look at, very high-end technologies. We looked at a lot of different things. So, and from that, FTIR spectroscopy came out ahead. And we did this kind of a, strength, weakness type review of every one of the technologies. When we look at FTIR, here are some, you can see the strengths here, and the big one is it can detect all the organics and many of the inorganics. And I want to be clear, it can detect all the inorganics except for those that are like sodium chloride or potassium bromide, which are very simple salts. All the other ones, it will pick them up. It's really common. Almost every lab has it. It's been around for over 100 years. ATR, especially with the diamond interface, is a newer technologies in the last 20, 25 years that's really been perfected. I'll show you here a little bit that, you could do this. I could show you in 10 minutes how to do it, and you would be able to run this test and get your answers. So because it's a fingerprint of all mixtures, it allows us to, tell which product it is, whose product it is. If your formulation is special, it'll detect that. So, and as we know, counterfeits don't always make, our products. So being around 100 years, there's spectra libraries out there to find almost any compound. Again, because it's a fingerprint, the libraries can be used to search, just like the police use fingerprints of people to find people. So it is semi-portable. It, as I said, it fingerprints all the mixtures, and contract laboratories, I've gotten it for, $100 if you do enough of them there. So the weaknesses, though, are some of if you have low material in there and a lot of other compounds, it might get hidden. Although the device is semi-transportable, it is still somewhat clumsy to move around. And you have to open your container and pull a sample out. So when we looked at all the other devices, this was the one that seemed to fit as best it could. So let's talk about, what is FTIR? So you see all these little vibrating molecules at the bottom. These are all the possible vibrations that you can see in an atom can make. So what mid-infrared does is it measures these fundamental vibrations of these covalent bonds, right? And all these vibration groups in a molecule combine together to give this unique spectrum of molecules. And it has been scientifically proven that MidIR spectrum of compounds is unique to the compound and represents the fundamental unique properties of a compound. We can take that to one other level, and that is to say that this means that, a spectrum of a substance if it matches exactly, that we know it's conclusively that material. Now, I will add a little caveat to that. First of all, you always want to check your science with another technology, and we recommend that. But we've never really run into a situation where what we thought it was